Mostly.
Huh?
Mostly.
Okay. Well, the XY coordinate system is one called, or also called Cartesian coordinate system in old days. Cartesian coordinate system. And it's actually, this is invented by a French mathematician and philosopher, Rene Descartes. So he's the guy who said, I think, therefore I am. Very important philosophical statement. So basically is he was wondering how to describe a movement, like something move from one point to other. And what would be a good way to do that? How can he actually be able to use numbers to describe it? So he came up with this XY coordinate. Well, it's based on the number line, and number line by one dimension. This is what we learned. So this is one. The scale really doesn't matter that much as long as you keep the same scale. So this is one, this is two, this is three, and this is four. And this is a -1, -2, -3. Now, do you remember that? The number line?
Yep.
Okay. So he said, okay, I'm going to use two because I'm going to describe a movement in a two-dimension plane. So I can use just two. One is horizontal, one vertical. Then we got this is one, this is a two, this is a three, and this is a four, and this is a five. Then we got -1, -2, -3, -4, -5. So given that, if I know a point, then I'll be able to give a coordinate. Just like when you wants to find someone, go to someone's house and they just give you a home address, and that is also coordinate. And they actually have basically two set of things. So they have a street number, and also name the street. So the first thing you're going to find is the street. Once you find the street, then you just drive along that street, then you find the house number. And that's basically a coordinate. And also the GPS you got, that gave you the coordinates where you're at. So it's a very good way to find something in a say a map, where you map just two-dimensional plane. Okay, so if I know a point here, well, how do I know the coordinate? So basically, I'm going to looking down. This is called x-axis. This is y-axis. So I want to see if I'm going down to the x-axis, what number I got. So this is 4. So therefore, we write the x-coordinate first. And this one go back to here, then that's 2. So now we know this point is 4, 2. So that's how we know a point. And we can basically match any point to an order, is called ordered pair. So two numbers. First number is the x, we call x coordinate. And the second number is y coordinate. Okay, over here so far.
Yep.
Okay, so now if I put a point here, what is the coordinate?
2, 4.
Yeah, so we call 2, 4 pairs. Now, if I have a point, say here, what's that?
-4, -1.
Well, this side is -4, but if you go on this side, actually it's 1. So it's -4 and 1. Good?
Oh, yep, yep.
Now, if we have a point here, what's that? What's the coordinate there?
-3, -2.
Right, -3, -2, and what happens if you have here?
4, -2.
Or -2. Very good. Now this you can see that made into 4 quadrants. And from this quadrant, we call quadrant 1. And this quadrant, we call that quadrant 2. And this is called 3. This on this quadrant. And then this one quadrant is 4. Now, points on the line, they are not in any quadrant. Same thing here, point on the line, not in any quadrant. They are in between quadrants. For example, this point is 4, 0, because if you go looking for the y-axis, you hit 0 here. And that is not in any quadrant. Or this point is 5, 0, and they are not in any quadrant. Good so far?
Yep.
Okay, now having that, we can use this to graph equation. So for example, we have y plus x equals 3. So this is called linear equation, 2-variable linear equation, and which is different from this kind of equation. Now this is called the linear equation, 1-variable linear equation. So in this case, this number is fixed. This actual number in the old days, we call that as unknown number, because that has to have a specific number. But in this kind of equation, we got 2 variables. In this case, x, y are 2 variables, because x can take any value. But if x take a value, then y value is fixed. For example, we can do, in this case, if we got x is 0, then this equation becomes y equal to 3, so we know y is 3. If x is -1, then this equation becomes y minus 1 equals 3, then y is equal to 4. Good?
Yep.
So therefore, in order to graph this equation, we know that there are infinite number of order pairs. And it happens that this kind of equation we call linear equation, that when you plot it, you actually get a straight line. So for example, if we want to rewrite this, we can say this is our x, this is our y, 0, 3. So that's give us 0, 3. Well, that's 1, 2, 3 is here. And if we equal to 2, then we become y plus 2 equals 3, then y has become 1. This is 1. So we got another, so 2, 1. So therefore, 2, 1 is 1, 2, 1 here. And then if you find other points, like say if you got a 4, then y plus 4 equals to 3, then y is -1. So 1, 2, 3, 4, and 1. You can see that if you find more points, and you find that all the points will make a line, and you make a line like that.
How did you get the 2 with the 1?
Well, if y plus x equals 3, if x is 2, what happens to y?
Well, how is x 2?
Well, x can take any value.
Oh.
For that variable, actually call that independent variable.
Oh, okay. So you're just seeing what adds up to 3.
Right. Yeah.
Oh, okay.
So basically,
Yeah.
give a y value, we should have x value, give x value, we should have y value. So that's why they're called order pairs. Good?
Yep.
So now we draw a line. So that's how we actually can graph linear equation. Basically, is finding, because we're doing a straight line, we all just need actually two points. Any 2 points make a line, right? We'll define a line. So we just actually need 2 points. And sometimes we take 3, just help us to be more accurate when we plotting it. Make sense?
Yep.
Okay. So let's see a couple examples. This is one. Now, if I have something, say, 2y minus x equals to, say, 3. Now, remember, it doesn't matter what points we take from that, but in order for us to graph it, we just want to keep them, make sure they all got even numbers. So the 2y is even number. So in order to make y as a integer, we just keep x as odd, because odd plus odd is even. So we can actually rewrite this equation to 2y equals x plus 3. Good?
Yes, but how would that work? How can changing it can you get the same answer?
Well, because this is the equation, right?
Yep.
Now, by the addition property equality, you can add same thing on both sides, right?
Yep.
So that's the if A is equal to B, then A plus C equal to B plus C. So, but I want to add X because I want to move X to the right. So this become X. Then this side, X minus X 0, got 2y on the left, but on the right it will be X plus 3. Good?
Okay. Yep. That makes sense.
That means these two equations are equivalent. But the reason I write like this one help us for me to find points. So I'm going to keep this side, we know it's even, so we want to keep them even. So therefore, instead taking x is taking 0, I put 1 here. Then 1 plus 3 is 4. Then 2y equal to 4. Then y has equal to 2. So I find that. Good? Are we good on here?
Well, I guess I didn't understand that how you got 4 and then it equaled 2.
Well, what happens if x is 1?
Uh, it equaled 4.
Yeah, this side is 4, but on this side still 2y, right?
Yep.
Then y has to be a 2, right?
Oh, so
Right,
2
right, on
times
both sides.
2. Oh, okay. Yep.
Okay, so basically saying like, as long as we have this equation, and if x is 1, then y has to be a, a fixed value, and that value has to be a 2, right?
Yep.
Because the equation here, we have to keep that true. So then we got, then we pick another one. If I pick 3 here, what will be our y? Then we got 2y equals to 3 plus 3. Now this side will equal to 6. Now 2y equal to 6, then we divide by 2, then y has equal to 3, right?
Yep.
Okay, we got 3. So I want to find one more. Doesn't matter which one we do this one. I can do say x equal to -1. Now if x is -1, then we got 2y equal to -1 plus 3 is 2. Divide by 2 on both sides, y is 1. So -1, 1. Good.
Yep.
So we got 3 points. Okay, where's negative 1? 1. Negative 1 is here. 1 is here. So this would be this point. So go up and it will be that point. Okay, and 1 and 2, 1 is here. Go up by 2, which is here, this point. Then 3, 1, 2, 3, and it's going up. 1, 2, 3, and that's the interception. So we know this one is 3 and 3. Good.
Yep.
Now we just need to connect them. Okay.
Yep.
Let's try. Okay, let's try a couple more here. Okay, we got say 2y minus 3x equal 1. Okay, so we're gonna make an xy table. Now this is x, this is y. So x is called independent variable. That means x can be any value. Y is called dependent variable, which means that once we know the x number, we know the equation, then the value of y is fixed. Okay?
Yep.
Okay. So x is the independent variable, so we can pick any number. So if x is 0, then this becomes 2y equal to 1, then y is half. Oh, we've got that one. Now, if x is 3, what happens?
Is it
Then
-1?
2y minus 9 equal to 1, right? 3 times
Uh,
9, right?
yeah.
Yeah, so, okay. Now we add 9 on both sides. Then 2y equals to 10. Then y is 5, right? Are we good here?
Yep.
So we're going to just pick another one. Doesn't matter what pick. So if I pick -2, see what happens. If I pick -2, then I got is 2y minus 3 times -2 equals to 1. Then that's 3y plus 6 equal to 1. So that's just a linear equation. So 3y is equal to -5. Sorry, not 3y, 2y. Then y is -5/2. So it's -5/2. So this is 0.5 and this is -2.5. Good.
Yep.
So where's a 0 half will be here. 3, 5, 1, 2, 3. 5 is, we go up. 5 is 1, 2, 3, 4, 5 will be right here. And -2, -2.5. So -2 is here, -2.5. 1, 2, then 2.5 will be here. So that'll be this line. And so therefore, if we have a ruler, then we should be able to connect them like that. Good.
Yep.
So now with that, then we can actually use the XY coordinate to help us solve system equations. And that's something we got reviewed on last time. Now, remember system equations, how many ways we can find the solution? Do you remember?
Say that again.
To solve system equations, how many ways we can solve it?
2.
Yeah, one is
Elimination.
right. The other,
Substitution.
substitution. Yep. Now we can also use graphing it to graph. So basically, we got two linear equation here. So if we're graphing it, then the intersection is a solution to this system equation, because on the intersection, XY meet this, also satisfy this. So let's see, XY equal to 10. We're going to here, X and Y. So I'm going to pick X, say 4, then Y has to be 6, right? 4 plus 6, 10. Good.
Yep.
And if X is 6, then Y has to be 4. And if X is 8, then Y has to be 2, right?
Yep.
So we got 4, 6, 1, 2, 3, 4. We got this line here. 6, 1, 2, 3, 4, 5, 6 will be right here, right?
Yep.
Okay, then 6, 4, we got 5, 6. 4 is 1, 2, 3, 4. So we got this point. And 8, 2, 7, 8, 2 is 1, 2 will be this. And you can see that we can draw the line like that. So it's one line. Okay. Now I need looking for the next equation. Let me put on here. X minus Y equal to 2. Then if X is 0, what happened to the Y?
It has to be a 2.
Well, X is 0, so this becomes minus Y equals 2. So Y is negative 2. Okay?
Oh, okay. Yep. Yep. That makes sense.
Then it's negative 2. Now, what happens if it's 2? X is 2, so 2 minus Y is equal to
0.
yeah, got 0. Now, what happened is equal to 4.
It'd be 2.
So there'll be 4 minus Y equal 2, so Y has to be a 2. Very good. Well, 0, comma negative 2 will be here. And then 2, 0 will be here, right?
Yep.
I'm going to use different line here. We got here, here, and 4, 2, 1, 2, 3, 4, 4, 2 will be here, right?
Yep.
So if we draw a line here, make sure we draw the line here. Now we have an intersection right here, okay?
Okay.
At this point, what's our coordinate?
6, 4.
6, 4. Very good. Well, that means here at this point, x equal to 6, y equal 4. Well, let's plug in. 6 plus 4 is 10. 6 minus 4 is 2. So this is a solution of this system equations.
Can you do that for every one? Huh. Yeah, I like that way a lot more than all others.
Okay. Okay, let's looking at other another example. Yeah, the tricky one is you got to use a ruler to do this. Okay. Now let's find we have some examples we got from previous. Okay. Now we got another one here. Is 3x plus 2y equal to 15, and 2x plus 3y is 25. So let's see how we do that one. Okay, well, let's do first one. 3x plus 2y equals to 15. And notice that 2y is an even number. Now, in order to, but the sum is odd, so therefore this has to be an odd number. So odd plus even is odd. So that way we can put this as even. So y we got will be a integer. Okay, so therefore we can pick one. Now, if that's the case, 3 times 1 is 3, so it becomes 3 plus 2y equals 15. Then minus 3, and we've got 2y, and this is 12, then y is 6. Good?
Yep.
So I'm going to use 3.
So y always stays still? It's the I don't remember what you called it.
X is called independent variable, so x can be any value.
Okay, but y has to
Right.
stay.
Yeah, y has to y is fixed based on the x value and also the equation.
So it'll always be y, or
Well, we have two variables. One is x, one is y. Okay.
yep,
If we know x, we should be able to know y, right?
yep.
So that's how we got there.
Oh, okay.
Uh-huh. All right. So if that's the case, x is 3. 3 times 3 is 9. 9 plus 2y is 15. Then minus 9 on both sides. Then 2y is 6, right?
Yep.
Then y is 3. So we got 3 here. Then we pick up 5. And that's 15. So got 15 plus 2y equal to 15. Then minus 15. Then we got 2y equal to 0, and then y has to be 0, right? Good on this one?
Yep.
Okay. So now we can graph this one. Where is that? And we got 1, 6, 1 here. We go up by 6. 1, 2, 3, 4, 5, 6. So it's there. And 3, 3. 1, 2, 3. Then 1, 2, 3 will be that. 5, 0. 1, 2, 3, 4, 5 be 0. So that line is going to be like this. Okay.
Yep.
And I put 2 arrows here. I mean, that just means there's a line going on both sides forever. Okay. That's where you put an arrow there.
Yep.
It's the line. I mean, a line has no beginning, no end. So that's what indicate that. But when we join it, we have to join in a finite space. So we just use that to indicate either way they can go in that mean infinite. Okay, we'll find this one. Now we need to figure out the second one. Okay, let's write down here 2x plus 3y equals 25, and x and y. And now we can see this is odd, and we want to keep, if we want to keep this one, if we want to keep this one as a whole number, then depends on the situation. Okay, so we want to make this side is divisible, the whole thing. Well, let's make couple. Okay, so if this one is 2, x is 2, then we got 2 times 2 is 4. 4 plus 3y is 25 minus 4 on both sides, then 3y is equal to 21, then y is 7, right?
Yep.
All right. So going to find other places. Then we basically we can pick 5 here. No, not 5. 2 plus 2 go 3. 9. 2 times. Yeah. We're going to pick up this as pick this as 5. And then will be 2 times 5 plus 3y equals 25. Then it's 10 plus 3y equals 25. Then 3y will be 15. Then y will be 5, right? Good.
Why didn't you subtract 10 from both sides?
Yeah, I did.
Oh, you just didn't show it?
I didn't show it.
Oh, okay, yeah. My brain doesn't work like that. So when you did that, I'm like,
Okay. All right, that's fine. Are we good here?
yep.
Okay. So 5 here. And then the reason I increased by 3 is because there's a 3 there. So that way I can keep that as integer. So basically I want to make, remember this one, we can rewrite that as 3y minus 2x plus 25, right?
Yep.
Yeah, so I just want to make sure this part is a multiple of 3. So then to make sure this y is integer. So I'm going on 8. If that's the case, 3y is equal to minus 2 times 8, 16, right? Okay.
Yep.
And then that equals to 9. So y will be 3. We got 3.
But can you leave it the way it was and then do it?
Like what?
Uh, can you leave it in the other equation
That's
form?
here.
Yeah.
Yeah, you can.
It just makes it a little bit harder.
Uh, it it'd be easier if we just put the y on one side and x on the other side.
Oh, okay.
Because you basically find, given x, you find y, right? Otherwise, you have to do it. If I leave it like this, I would say 2 times 8, 16 plus 3y equals 25, then I minus 16. You can do that. Good.
Yep.
But if I change it to 3y equals negative 2x, so basically I already have, then I just changes this to 8 is negative 16 already. Okay. So we
Yep.
can save a step. Make sense? Yeah.
Yep. Yep.
So now we can see this one, 2, 7, where's that? 1, 2, 7. We got 6 here. 7 has to go up one more. So somewhere there. Somewhere there outside. Okay, 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 will be that. And A3. 1, 2, 3, 4, 5, 6, 7, 8. A3. 1, 2, 3. So, well, unfortunately, in this case, they are going to intercept up there. Okay, it's kind of outside of the graph. Now, to help us to do this, then we can change this coordinate scale to help us to do that, because I want to see this one. We do not see it, so we're going to make that outside a little bit. So I'm going to draw I draw my X down here. Really just doesn't matter where you're drawing it, and draw my Y kind not here.
If you had a graph sheet, could you just go up high enough and find it?
Right.
Okay.
Don't have that. So
Yep.
1, 2, 3, 4. Well, I need 8 on that, so I have moved that out a little bit. 1, 2, 3, 4, 5, 6, 7, 8. So it should be here. So now let's see. The first one is 1, 6, 1 here, 6, 1, 2, 3, 4, 5, 6. And another one is 3, 3. 1, 2, 3. 1, 2, 3 will be here. Then 5, 0. 1, 2, 3, 4, 5, 0. So we have this line there. Then we got 2, 7. 1, 2. This is 6. 2, 7 is here. And 1, 2, 3, 4, 5, 6, 7. Yeah. 5, 5. This is 5. 1, 2, 3, 4, 5. And 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, 3, 1, 2, 3. So we got this line here. So it's something like that. Okay. So it looks like it's here. This is our 7, 8. Looks like here is 8.5 on the Y, and this side is negative 1.85. And so if we are using a graphing paper, then you can get more accurate on that.
But your point where they cross can be on the other side of the.
Right. Now, in this case, there will be somewhere here.
Okay.
Okay.
Yep, that makes sense.
Yeah, looks like could be 9 here. Let's check. If this is negative, X is a negative, so negative 3 plus 2y equals 15, then 2y is equal to 18, then y is 9. Here, if X is negative 1, so negative 2, 3 times 9 is 27, negative 20, negative plus 27, 25. So actually the answer is negative 1, 9. So we're pretty close. Good.
Yep.
Okay, let's just do one more. We got 4x plus 3y equal to 30, and 3x minus 2y equals 15. Okay, so I'm going to change it in a way that it's easier for us. So I'm going to change this one to 3y equals to negative 4x plus 30. Okay.
Yep.
And I'm going to divide by 3 on both sides. So if I do that, we got y equals negative 4 over 3x, and this side will be 10, right?
Yep.
So because we're going to trying to find y anyway, so I might as well write in this form. So this becomes y equals to negative 4 over 3 x plus 10, and that also help us to find the points. And this one, 3x minus 2y equals 15. Then if I add 2y on both sides, I got 3x equals to 2y plus 15, which is same as 2y equals 3x minus 15, right?
Yep.
And divide by 2, so y is 3 over 2x minus that, which is 15 over 2. So we got y equals to 3 over 2x minus 15 over 2. Good?
Yep.
Or we can rewrite the second one as 3x minus 15 over 2. Good?
Yep.
Okay. So let's find the first one. For the first one, we know if x is 0, then this part is 0, y is 10, right?
Yep.
And now writing this form helps a lot. I just not, as long as x is multiple 3, and y will be an integer. So I pick 3 here. And so that gives us negative 4 plus 10, that's 6, right?
Yep.
Okay, then I pick 6, then 6 divided by 3 is 2 times negative 4 is negative 8 plus 10 is 2. So we got 6 there. Good.
Yep.
And we can also do the second one. We got x, y. Now we can see that in order to make the whole thing a even number, x has to be odd. So if x is 1, so 3 times 1 minus 15, that is negative 12, but they have divided by 2, so it's negative 6, right?
Yep.
And I put 3 here, so it'll be 3 times 3, which is 9. 9 minus 15, that is negative 6, divided by 2 is negative 3, right?
Yep.
Then I pick 5. 3 times 5 is 15. 15 minus 15 is 0, so got 0. Good?
Yep.
Okay, so now we're going to graph that. I can make a line here. So because I have to go to 0, comma 10, so I put a line here. This is my x, and this is still my y. Okay, so for this one, 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 3, 6, 1, 2, 3, go up by 6. This is a 1, 2, 3, 4, 5, 6, so it'll be here. 2, 3, it'll be here. Then 6, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 2, 1, 2 will be that. Okay, so I already did on that one. So the line will be like that. Good.
Yep.
Okay, so the other one, we got 1, -3, 6. So it's kind of below that. So I'm just pick 3, -3. So go 1, 2, 3, -3, 1, 2, 3. That's 1. The other one is 5, 0. 1, 2, 3, 4, 5, 0. Good. Yeah. So I'm going to pick another one. So like I can join it. So I'm going to pick 7. So that'd be 3 times 7 is 21. 21 minus 15, that is 6, right? Divide by 2, so it's 3. So we got 3. Yep. Are we good on this one?
Yep.
Okay, so we got 1, 2, 3, 4, 5, 6, 7 is here. 3 is 1, 2, 3. Be here, right?
Yep.
And then we just draw them together. Okay. Well, so we're that. It's kind of close to here, which is 6, 2, right? We got 6 here. 1, 2,
Yep.
close to that. Well, let's check if that's the case. Now, if x is 6, 6, we plug in here, or we can plug in there, doesn't matter. So plug in on top. X is 6, this is 24, right? Good.
Yep.
Now, then minus 24 on both sides, then 3y is 6, then y is 2, right?
Yep.
So that works for this equation. We just want to check here. 3 times 6 is 18. We got 18. Y is 2, so 18 minus 4, that's 14. So not exact. So we're kind of off a little bit. Good. But
Yep.
because I'm hand drawing it, if you use graph paper and also ruler, you should get more accurate result.
Okay.
Good.
Yep.
All right. I'll see you next time. Okay.
Yep. See you later.
Bye.